attention, say, to my Gmail account here, we're actually going to get a second one because I was just testing. In my Gmail inbox is a very simple email like this. So it was sent to it was sent from mailin@cs50.net. I logged into our email server as jharvard@cs50.net. And this is, of course, not all that interesting as it's written here. But I do know that this person's name is David. The checkbox was on, Mail, and Matthews. And if we wanted, we could certainly format these emails a little more cleanly. Of course, this doesn't scale very well. And even if we implemented the Frosh AM's website for the proctor by sending him or her emails, then this person has to start organizing these emails into folders and figuring out who's registered. It'd be much nicer if we could somehow create a database for all of these registrants, or create an Excel file even, so that the proctor can manage the volume of registrants a little more cleanly. So for this, we actually need to introduce a little something called MySQL. So MySQL is a free database server. A database server is something that allows you to store your data in tables, or more specifically, a relational database server is something that allows you to store data in tables. And what do we mean by tables? Well, think again to Excel spreadsheets. These things have rows and columns. That is sort of a very simple database where you can have columns that mean something like name and email address and phone number, and every row represents an entry in that database or in that Excel spreadsheet. So this is a screenshot of a tool that we're about to see and use called phpMyAdmin. The fact that this tool is called PHP something is a coincidence. The tool happens to be written in PHP, but we're using it because it's a useful tool with which to manage tables on a server. MySQL is that server. It's, again, free software. It's very high performing. And to this day, much of Facebook is implemented with MySQL underneath the hood. It can be scaled up to many possible servers. We, in the case of the appliance, of course, are just using one server, our own. So this is a screenshot specifically of a table that you're getting or have gotten with problem set 7 that we pre-created for you. And we give you a little text file with which to create this structure in your own appliance. And even though there's a bunch of icons on the left, this table is actually even simpler. There's only 3 columns: an ID column, a username column, and a hash column. And this table collectively we call the users table. And the idea here is that when you download pset 7 for the first time, what you have is a slightly functional product. You have a product that looks a little something like this. If I go to the staff's own implementation at cs50.net/finance, you'll see a user interface a little like this, but you won't have the big yellow banner there saying that this is the staff solution. But what you do have by default is a bunch of temporary users: a jharvard user, a Scroob user, a Mailin, a Arbodin, a Matt's account, and others, so that you at least have some sample data with which to work. And so the format of that table is as follows. We apparently have an integer representing their ID. Their username is whatever they chose upon registering. And the hash over there is supposed to be their password, but it's not really. So if you think way back to problem set 2, when we talked about cryptography, some of you might have bit off the hacker edition of the crypto pset, which actually had you crack passwords that weren't quite encrypted like this, but were in some similar fashion. Why, apparently, are we proposing in our database to not remember users' passwords, but instead remember their hashes thereof, whatever that is? What was a hash of a password, or hash in general? This also relates, actually, to pset 6. Yeah? OK, perfect. So the point of hashes generally is to make it harder for a bad guy who steals, for instance, this database, or breaks into my web server and somehow gains access to all of my user data. It's a really bad situation if they not only get my user data, but also get my users' passwords, right? Because there is probably a non-trivial number of you in this room who are using the same password for your email, for like your PIN account, frankly, for your fake CS50 finance account, most likely. And if that data is not encrypted or not hashed, what that means is that all these websites you've been logging into for the past couple of years, if you're using the same password and the people who implemented those sites are not particularly security conscious or savvy, you might be telling half the world who runs these servers what your favorite password is. Because if you don't actually encrypt it or, again, hash it, much like we created a hash function in pset 6, if you don't somehow scramble the input and then save that input, but the alternative is the worst, which is just storing the actual password. So long story short, you will see in pset7's distribution code the use of a special function called crypt, which is essentially a hash function that, given a password like 12345, will create nonsense that looks like this. But the key feature of this crypt function is that if you call it again in the future and give it again 12345, it will return exactly the same cryptic value. So the idea is when you check passwords, you don't check what the user typed in against what's in the database. You check what the user typed in after it's been passed to the crypt function again against what's in your database. And statistically, it should be very, very hard to convert these cryptic hashes back to the original inputs. And for the curious and for those struggling to actually log in to CS50 Finance, these were the answers to the hacker edition of Problem Set 2. And all of the passwords that we gave to the hackers in the class were ranged from the simplest, for Caesar's 13. Rob's was noob, Matt's was leet, and mine, I dare say, was the hardest, which I think this year no one got. But these are the same passwords that we've given you just as sample users for problem set 7. So how do we actually use MySQL and use these tables? Well, know first that SQL is the language we're now about to start using. So SQL, structured query language, is not so much a programming language as it is a database language, a query language per its name, that allows you to select data from a database, insert data into a database, delete from it, update it. So in short, all these things we take for granted when using Excel, like double-clicking on a row and typing and deleting a column and so forth, those can be summed up as deletions and inserts and updates and select, where select is one of the most useful. That's the search, like give me something from this spreadsheet, give me something from this table. So we're about to start constructing queries that allow us to grab data in this fashion, and we'll use phpMyAdmin as a specific tool with which to actually configure those things so that we can implement a little something like this. So let me go back to the appliance, and I'm going to go ahead and open up Firefox. And I'm going to go not just to localhost this time, which recall is my actual web server. I'm actually going to go to /phpMyAdmin. And when you go here, you'll be prompted to log in with jharvard Crimson. So to be clear, phpMyAdmin is an administrative tool on the web server, aka the appliance. You should not be trying to log into phpMyAdmin as Scroob or as Matt or as Rob, but rather as you, John Harvard, because John Harvard in this case, aka you, is the webmaster. So when you log into phpMyAdmin, frankly, its UI is kind of a train wreck. There's way too much going on to be compelling, but there are some very handy features that are much more user-friendly than the alternative, which would be a command line. So notice at top left here that I followed some instructions in problem set 7 that said import this database. How do you do that? We literally give you a big text file. It's called pset7.sql. You essentially highlight it and copy its contents into this big SQL window here. Click Run, and voila, you now have a database. So for now, you're seeing the end result of that process that the spec will walk you through. When I click Users, now we see the web page that I took a screenshot of a moment ago. And again, I have an ID field, a username field, and a hash field for their password. But let's start this from scratch with regard to Frosh IMs. Let me go ahead and do the following. I'm going to go over to the home page again. I'm going to click Databases, and I'm going to create a new database. Let's call it jharvard week 9. As an aside, John Harvard has the privileges to create any database so long as its name starts with jharvard_. This is a typical MySQL convention. I'm going to click Create, and now notice it executed this. So this is what phpMyAdmin does. It simply simplifies the execution of slightly more arcane commands that, again, I could type at a blinking prompt. For instance, to create a database, you could literally type at the right command prompt, create database jharvard_week9. This GUI-based tool just makes it a little easier to do so. Now, if I scroll down here, it's telling me no tables found in database. So you can think of a table like an Excel worksheet specifically, and an Excel file as a database that can have multiple worksheets or multiple tables. In this case, I want to go ahead for Frosh IMs and create like a registrants table, the kids who have registered for some Frosh IM sport. And how many columns? Well, I've got 4, I think, right? Name, gender, captain, or dorm. So 4 fields in that case. So let me go ahead and hit Enter. And now I'm going to get this form here. Again, this is not the most user-friendly design in that you have to scroll all the way to the right. But let's at least tease apart what these fields are. So first, in column, I'm going to name these fields. Name, captain, this is going to be gender. This is going to be dorm. And now, what types do I want to give these? Well, notice that MySQL is different from C. It's different from PHP. It comes with a whole bunch of data types, frankly, almost all of which are self-explanatory, especially like float and double and int, because we've seen those before. Int we used for an ID, but for name, I need something like a string. And here's the string-related ones. And the two that are most interesting now are char and varchar. Long story short, if I choose char, that's actually more than a single char, because I can say everyone's name in this database is going to be no more than, say, 64 characters. And by typing 64 in that box means MySQL's going to create a column that's just wide enough for 64 character strings. Now, the downside of this is that, like in C, if I allocate 64 characters, every name is going to take up 64 bytes, which is probably excessive for a lot of our names. So there's instead a data type called varchar, variable char, where you can say 64 is the maximum length, but be smart about this. Only use as many bytes as are necessary to store the AVID space MALAN, right? That's only 11, maybe a new line character or a null character. So 11 or 12, that's much more efficient than using a char itself. So quick sort of thought question. Even though we know nothing really about MySQL or how databases are implemented, what price are we probably paying if I'm not using a char, but instead using a varchar, which seems like a win, right? I'm using less space because I'm only using as much as I need. But what's the hidden cost probably, as has been a theme in the class? Yeah, performance, right? So it turns out, so speed, performance, whenever we talk about these trade-offs, it's almost always time or space. In this case, we win on space, we lose on time. Now, this is not worrisome for small databases, but again, for large websites with hundreds or thousands or tens of thousands of users, there's an advantage to having every username 64 characters, even if most of those are just blank characters. Why? Because just like an array, you can go from here to here to here by just doing plus 64, plus 64, plus 64. If you instead use variable length strings, how do you find someone's name? Well, you kind of have to scan the whole list in the worst case, because you can't jump from name to name because they're not all on the same boundary. In other words, you have ragged edges in your column. They're not straight like this in Excel. They're kind of different lengths all around. So that does not lend itself to performance. So that's something to keep in mind. So for now, varchar is almost always fine, unless you're really, really worried about performance. 64 might even be, well, 64 is pretty generous, but we can even make this 128 since we're using variable chars. But you do have to decide. Captain is going to be something like a yes or a no. So I'm actually going to use the Boolean field. So that can just be a 0 or a 1. Gender, I actually have a few options. I could do something binary with Boolean. I could use a string. I could use a number. So we could actually go a few ways here. For simplicity, I'm going to go ahead and choose, let's say, a char. Let's say, where'd it go? Let's do char, because my form is hard-coded right now as M or F. So if I'm only going to restrict to those two choices, let's just use one single char and not worry about Booleans and such. And then lastly, dorm. This could be a char or a varchar. You know, no dorm name is greater than like 128. Whoops. Sorry. Like this we made char. Not even sure what that would mean. OK, varchar. All right, 1. Gender, char, 1. OK, there we go. Captain. Oh, I'm all over the place. All right. Varchar, let's say 128. Why? Just because. It's the same. You have to make a decision, so you might as well pick something consistent in this case. So there's a bunch of other fields we can choose.